Hey guys, welcome back to Leetcode, and today we'll be continuing with our arrays topic in our top interview 150 series. Today we'll be doing the question remove duplicates from sorted array. So we are given an array nums in an ascending order. We are supposed to remove all the duplicates in place. So we have to make sure that the unique elements appear only once and the relative order stays the same. At the end, we're supposed to return the number of unique elements in nums, not the array. You can read the rest of the question, but it says that you have to make sure that the first k elements of the array are unique. And we have to return that k. The custom judge is the same as the last question. It will just make sure that everything in nums is correct and that the value of k is also correct. I think this question is best explained with an example, so I'll just show you one. Let's say nums is an array given as this 0 0 1 1 1 2 2 3 3 and 4. You're supposed to return the number of unique elements and your nums at the end should look something like this: 0 1 2 3 4, and we don't really care about the rest of the elements. K should be equal to 5 as there are 5 unique elements, and we'll return this. Now the brute force approach that comes to mind is the same as the last question, so I would want you to check out that. If you know how to do it, then maybe you should try it yourself. The brute force solution would be that every time you see a unique element in this 0 0 1 1 1 2 2 3 3 4, every time you see a unique different element, let's say you see 0, then you move everything one step left. The last number would remain the same, like here it would be 3, but we don't really care about that. At the end you would have 0 1 2 3 4 and probably 4 4 4 in the end because 4 was here. And that would result in a time complexity of O of n square and a space complexity of O of 1, which does fit our requirements, but the interviewer will not be looking at this solution and would 100% ask you to optimize it. If you're a beginner, I would recommend that you try out the brute force solution first and then only move on to the optimized solution. Now look at this array. If you had to use your monkey brain to figure out how to go about it, what would you do? You'd remember where you have to place the next element. So you saw 0, you're like, wow, this is new. You move on to the next element. You see, oh, this is not new. So you remember this. Let's say you remember this with k. Then you keep going forward to find newer elements. Let's say you use I for that. You saw 1, you're like, wow, this is new. So you replace 0 with 1. Then you keep searching. So then you put your I here, 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 and you're like, wow, you saw 2, but you already replaced this. So you'll replace the next element with 2. Then you kept moving forward. You found 3. You replace the next element with 3, and so on. This is how we are gonna do it. We are supposed to remember where we have to place the next element with one pointer, and we'll keep traversing to find newer elements with another pointer. So this will be a 2-pointer question. Now how will we check if an element is new or it's not new? Let's say you're traversing with the pointer I, it's here. All you have to do is check I minus 1, and if it is not equal, then the element is new. If they are both equal, which means it's not here for the first time and you've seen it before. We could have put both k and I on the first element, but remember, this will always be new. This can never be old because we have nothing to compare it with. So we'll always put k and I on the first index, which is the second element. Now there can be two situations, but I think you'll better understand them when we go and try the question. So you're traversing with I. You check I minus 1 and this time they are the same. So the first situation is where they are the same. So you don't actually have to replace anything, you have to keep traversing with I. So you just move I to the next element. So if they are equal, you just do I plus plus and nothing else. Now you are here. You check it with I minus 1 and they're different. So the second situation is where they're not the same. Then what would you do here? You would replace this element with I. So what you'll do is you'll replace nums k with nums I. So this will now become 1. Then you would move your I pointer forward to this place and you'd move your k pointer forward to this place. So you do I plus plus and k plus plus. And you'd keep doing this till the loop ends, which means I reaches the end. The time complexity for this would be O of n. You can say it would be O of 2n because there are 2 pointers, but at the end, in the long run, it would boil down to O of n. The space complexity would be O of 1 because we have used no extra memory and this satisfies all our conditions. This will be the optimized solution. I'll show you guys the pseudocode now. So we'll set our k pointer to 1. We'll run a for loop for the traversal for I. So we'll run I from 1 to end. Remember to start it from 1. Then if nums I is not equal to nums I minus 1, what will we do? As we have already discussed, we'll set nums k equal to nums I. We'll do the replacement and we'll move k forward. Now if you see clearly, we were supposed to increment I on both anyways, and I is automatically incremented in our for loop. So we are not supposed to do it ourselves. This will be the pseudocode. The code for this will also be very similar except one edge case. You're gonna set k to 1. You're gonna run a for loop for I, and if it's not equal, then replace it and increment k. So if it's not equal, our k is incremented here, our swap happens here, and I is automatically incremented. Even if this doesn't come out to be true, I is still incremented and you still get your conditions. At the end, you will return k, which is the number of elements. And if you know you're incrementing k, k will automatically contain the number of elements that are unique because of the location where k is placed. Every time you see something different which is unique, you're incrementing k. So you're basically also counting the number of elements. So this will work out. Also remember to add this edge case if nums.empty, then return 0. Because if you're given nums and it's already empty, then this whole code would fail. At the end, this would result in a time complexity of O of n, a space complexity of O of 1, and that would be the end for this video. If you have any feedback, any comments, do let me know and I'll make sure to incorporate it in my next video. Thanks for watching.